Hello, Professor. We are Team Neural Knights, and our team consists of Pranati and Chaitra. So today we are doing a podcast generator as a part of our project. So let's dive into our project. So what have we done? So we have actually divided the entire project into three parts for the ease of understanding. So in the first part, it is about fine-tuning the simple GPT-2 model on the podcast data. And the second part is about generating the audio output using the LevenLab TTS. And the third part is the Streamlit application for giving the podcast topic to the model. So let's discuss each part in detail. So we will start off with downloading the model. So here is the code we have downloaded the model. We have used two models. One is 124M and the other is 774M. So in 124M is where we did our project, because 774M was much runtime intensive, but we have tried on that as well. Next, let's discuss about the experiments we did. So in our project, we actually had two data sets. One is the Harry Potter books, which we took all the 7 Harry Potter books. So since I and Pranati are Harry Potter fans, so we actually wanted to do a podcast which is discussing about Harry Potter books. So here what we did was, so our foundational model, which I mentioned earlier, was GPT-2 Simple. We fine-tuned that on all the text data of all the 7 books in the series. I have the Colab, which I will be discussing further. Here we loaded the model and we prompted, and in the next slide I'll be showing you the results. So here is the result. So here, as you can see, there is Harry Potter and Ron Weasley are making podcast. They like to discuss about the events in year of chapter 1. So, and if we read the output, it says, "I thought I would have a look around before tonight," said Harry, "but I don't think we'll see it anymore." So as we can see here, the output of our model is more on the bookish style rather than being on a conversational style, which is more adapt for podcast. So this was our experiment 1. In the next stage, we proceeded with collecting data with podcast data specifically. So here we got Lex Fredman. He is a renowned podcaster. So we took his data set. We got it from Hugging Faces. And this is the podcast, and the link we have added in the README file of a GitHub profile. Next, this is us loading the data for the training purpose, basically fine-tuning purpose. Now, when we are fine-tuning the model, this is the code wherein we are fine-tuning the model with the podcast data. And this is where the fine-tuned model is like, it's loading the data set and it is fine-tuning. So here we can see the loss and the average. So then after this is us loading the data, which is already fine-tuned. So this is, we actually save it in the drive and then we take it. And then this is the model's output. So all this detail, all the details of the fine-tuning, Pranati will explain in detail. So here we can see that the output of the GPT-2 model, which is being fine-tuned. Here, as we can see, it says, "What do you guys think about machine learning? My favorite kind of thing." So it is more or less like a conversational style, which is more adapted for podcast. And and then this ends the first part, and next we come to our second part of the project. So the second part is once whatever the model has been generated, once the text which the model has been generated, we have to give a voice to it. Basically, there should be a narrator and other 2-3 characters in a podcast. So we generated this using ElevenLab TTS. We also experimented with 2 other libraries. One was PySX3 and GTTS. So with PySX3, there was more of there was more of just male voices. And as a result, we wanted female voice also to be included. And about GTTS, why we didn't go with GTTS is because it is more monotonous, wherein we cannot add 2-3 people to talk. So that is why we chose ElevenLab TTS. These are few of the advantages. It is more, ElevenLab TTS actually gives a very natural sounding voices, which is very much required for podcast. And then we have a customization options wherein a male voice, female voice, young, old, all of them, it's most inclusive and it's multilingual. So apart from English, if we want to make podcast in other languages, it is supported by ElevenLab TTS, and that is why we chose ElevenLab TTS. Next, Pranati will talk about BlueScores.
So we have actually used Score to evaluate the output of our model. So BlueScore is the bilingual evaluation understudy that measures the similarity between the generated text and the input reference texts. So we've actually got impressive BlueScores for our generated text from the model, and this indicates that the model has fully newly generated the text. So yeah, that's all about the BlueScore.
Okay, then we talk about Streamlit application. So here in the Streamlit application, we actually, why we chose Streamlit is because it was more intuitive framework. And the user is going to give us the topic. Like in our demo, we have chosen the topic machine learning. And once the user gives the input, we kind of, so to take the input from the user, we kind of use the Streamlit and to display the audio output, which we will show in the demo in detail. Thank you, Professor, for listening to our presentation. Then we want to go in detail. So the first part of our experiment was the GPT-2 text generating model based on Harry Potter data. So here I'm loading the GPT-2 model. So I'm sorry, I'm installing and importing it. And here, since we needed a GPU, so we are using NVIDIA T4 GPU. And in the next part of the code, as I mentioned earlier, we are using the model 124 here, and then we are going to mount it on the drive, Google Drive. And this is where we are loading the Harry Potter text. And then when after writing into the G Drive, we are selecting it here because once the instance of the Colab is destroyed, we might not get the we might not get the GPT-2. So that is why we are writing it to Google Drive and then taking it up here. So this is where we kind of fine tune. So this is where we are trying to kind of fine tune. So this is the text. So this is where it has loading, this is where it is loading and like calculating losses. Next, when we go, we kind of get the checkpoints here. And from the checkpoints, it is stored in the .rar file. And then we generate the text from the trained model. So as I mentioned before, it is more of it is not of a conversational style. So here it says Lord Voldemort was pulling himself free of the clutches of the demonstrators. So this is more like a third person referencing rather than direct conversational style. This is also one of the text which we tried generating. So we have used a lot of, so we tried using a lot of prompts to generate it. We gave the prompt, Harry Potter and Ron Weasley are making podcasts. They like to discuss about the events in chapter one. And then we tried different prompts, but still we got this. So that's why we chose the Lex Fredman podcast, which Pranati will be talking about.
All right, let me share my screen. Okay, so as Chaitra has already mentioned, we've experimented the model on Harry Potter books, and we've generated a text like books. So now as we've already mentioned, the goal of our project is to leverage the power of LLMs in podcast generation. So for that, we have chosen the GPT-2 simple model, as you can see, and it's a very powerful pre-trained language model developed by OpenAI. So it has been widely used for several NLP tasks like text generation. So we've chosen to specifically fine-tune this model on podcast data to generate podcast-like transcripts and then convert it into voice. So to begin the fine-tuning process, we have collected the data set from Hugging Face. So we have chosen the Lex Fridman's podcast data set here. Then okay, so we have actually cleaned this data, and then we've tried doing topic modeling on this podcast data using LDA technique. So we've done this to obtain major main themes and topics of the podcasts that we've chosen. So to perform LDA, we've cleaned the data, removed all the unwanted symbols and numbers of the text, and then we have done some tokenization, lemmatization, and we try to extract only nouns and adjectives from the data to generate topics. And then we've done LDA on this data to obtain these topics. So these are the topics that we've obtained from the podcasts that we choose. And this is the visualization of all the topic words and their frequencies. And yes, and going back to the fine tuning part, first we downloaded the GPT-2 simple model. We've actually used 124M as it was smaller and easier to fine tune this model. So this is where we downloaded the 124M. And then we've loaded the data set, the podcast data set that we've chosen, and then tried to fine tune this on that data set. It took a couple of hours for this to train this model. Then we saved the checkpoint of this model. We saved the model that we've trained on, and then we loaded back the model to generate podcast-like text. So yeah, this is one of the examples of the GPT-2 model, but let's see the output of the model that we have trained on. So yeah, so this is one of the podcasts that we've generated. So we've tried to generate several podcasts from this by changing the temperature and other components of this model. So we've after experimenting a few podcasts, then we've done the Blue Score. Again, as I mentioned, so the Blue Score is to evaluate the output of our podcast transcripts that we've generated. So it has actually given decent scores, as you can see here. So the model has totally generated new text Yeah, so this is all that we have done. And after generating the podcast transcripts, we've tried to convert that into voice. So I'd like Chaitra to continue talking about that.
Thanks, Pranati. Let me share my screen now. So here is where we have the voice generation part, that is so we are using two models. One is the GPT-2 Simple, which Pranati explained in detail, and now it is Turbo, GPT 3.5 Turbo. So here we are using this to here, sorry for that. So we are using this for narration. Basically, whatever text we get, there should be characters which has to be assigned. So in order to analyze the text and assign each character, so we are using GPT 3.5 Turbo. So let me take you through that. So as I mentioned before, why we opted for 11 lab TTS is because it gives us the flexibility of deciding whether our podcast is going to be a male, female, or whether what their age is going to be, and then what accent are they like they would prefer. And so based on that, it can generate attributes. So this is for to get voices. So here we have different voices. If we kind of click on this, okay, so this is where it kind of comes up. So we can choose who is the narrator going to be. So here we have Rachel, who is a female, and we have Arnold and Adam and other male voices and female voices. So there is an amalgamation of both. So that is one reason we actually chose 11 labs, which I mentioned earlier. And then we have text to speech. So based on that voice ID, whichever we have chosen, basically we have chosen Rachel, which we will, this is just the function. The function call is going to be in main, which I will be discussing in few minutes. So this is the function for which is going to convert text to speech, given the voice ID and the text. So voice ID is Rachel, the which I just showed now, and this is where it is going to play from the binary file, and then we will get the voice ID, and these are the voices which we can again choose from. Next, let me go to transcription. So this is what I was talking about when we are using GPT 3.5 Turbo, wherein we take what is the the system context. Here, the system context is where we experimented with a lot of prompts. So this is where we actually employed the prompt engineering. We learned about prompt engineering. So here we have given that this is supposed to be like an book, this is supposed to be like a podcast, and the different formats. The manuscript includes a narrator and the characters, and then in the beginning you provide a summary of all the characters, including the narrator. So this text output will be used by GPT 3.5 Turbo to kind of create that transcription. So using this is where the um, uh, using this is where the transcribed text is going to transcribe, and we are going to get the transcription. This is the main function where we are doing most of our function calls, like the one which we chose, like the narrator voice, which we chose as Rachel. So now let's head to the demo. In the demo, I just want to open the terminal, and this is our Streamlit application. If we give the command Streamlit run app, our app will start. So So this is where the app got generated. It's in local 8501. So it opened in local 8501. And this is our application. So in our application, when we give the term machine learning, and when we click on submit, let's look at the terminal. So it says it's running. Let's give it some time.
Rob and John discussed their thoughts on machine learning, a branch of artificial intelligence that focuses on developing algorithms and models capable of learning from data and making predictions or decisions without explicit programming.
Yeah, fully scalable neural networks. I've always just wanted to run what now I'd call natural language engagement and correlated learning models. That kind of stuff. That's right, John. Machine learning is indeed a branch of artificial intelligence that focuses on developing algorithms and models capable of learning from data and making predictions or decisions without explicit programming. It's a fascinating field that has gained a lot of attention and practical applications in recent years. It's remarkable to see how machine learning has evolved and become a significant part of our lives. The ability of neural networks to scale and process vast amounts of data has opened up new possibilities for various applications, including natural language engagement and correlated learning models. Absolutely, Edward. Natural language processing, for instance, allows computers to understand and interact with human language, enabling applications like virtual assistants, language translation, and sentiment analysis. It's exciting to think about the potential advancements we can achieve with these technologies. Correlated learning models, on the other hand, can identify patterns and relationships in data, leading to insights and predictions in various domains. I find the concept of machine learning fascinating as well. The idea that machines can learn and improve from experience opens up a whole new world of possibilities. It has the potential to transform industries such as healthcare, finance, and even entertainment. Indeed, Rob, machine learning has the power to revolutionize many aspects of our lives. However, it's important to also consider the ethical implications and potential challenges associated with this technology. Agreed, John. Ensuring transparency, fairness, and accountability in machine learning systems is crucial to avoid biases or unintended consequences. It's essential to approach machine learning with responsibility and consider its potential impact on society. Well said, John. Machine learning holds tremendous promise, but it's crucial to navigate its development and deployment thoughtfully.
So it says the audio generated successfully. So that was the complete demonstration of our entire project. So I would actually like to say that me and Pranati have learned a lot working on this project. Like from how to fine tune to how to kind of understand how these large language models are used and how it can be used. It has been a great learning for both of us. What say, Pranati?
Yes, we've learned a lot of things, and it was very, very much fun to work with LLMs. So, yes.
Okay, that's our demo. Thank you.
Thank
Bye.
you.